Okay, again, I believe long divisions are order, and one thing it's going to make it easier for me to deal with, like the degree of this thing is going to be reduced in every single case if I do the division. The divisions are also easy to do. So, 1 plus this, 1 minus this, 1 minus this, 1 plus this. You have to do the divisions though to get that. You can't look at that and say, gee whiz, how'd you get that? Well, if you don't know how I got that, you do the divisions, and there's going to be 4 divisions to perform. For example, let's say I did the second one. That's x minus 4 divided into x minus 5. It's a very easy division, by the way. What do you get? X minus 4. You get a remainder of minus 1. So what's the answer over here? 1 minus 1 over x minus 4. And that's where that's coming from, right? Every single term I do. Now, someone says, why do you do that? Well, it may get simpler, but more importantly, the degree of the top has been reduced in every single case, all right? So, I had a degree 1, now I have a degree 0, all right? Another thing I noticed about this over here is that 1 plus 1 plus 1 plus 1 is 4, and you could subtract 4 from both sides. And what do you get? Really something simple. So after I do that, I notice that I'm left with something rather simplistic looking. And what I like to do is, the positive terms on one side and then add the negative terms to the other side. So let's see if I did that. So I get 1 x minus 2, and then I get 1 over x minus 8. I see that. And then I took these two terms, and I added it to both sides, and I see that. All right? Now, the key here, as you're doing these things over here, these are carefully written problems, by the way, which is something I want to really compliment, Wells on. It took considerable effort to write these problems. It isn't like they just, came up with these and said, gee whiz, let's randomly pick some numbers. They carefully thought about what they were doing. There's no doubt about it. So, common denominator, not that bad to do. Not that bad to do. The numerator's a little bit more difficult, but in this case, it's not bad, right? You'd get 2x minus 10. On the other side, you would get 2x minus 10. Well, you know what? I'm in the same situation I saw before. So for this to be equal, 2x minus 10 could be 0. And that would make those two equal, which means x equals 5. And that's why that answer is written over there. And that is not a trouble number. That number makes the top 0, but the bottom's not simultaneously 0. So I'm comfortable with that answer. And then what I do is I divide that away, right? Then I work on the other answers to the problem. So what I'd be left with? Well, if you divide both sides by 2x minus 10, with the understanding that x is not 5 in that case, you'd be left with this over here. Then I do multiply both sides of the LCD, or what some people call cross multiplication. You get something like this, easy to multiply out. In both cases, by the way, you get you get x squared, minus 10x plus 16. Other side, you get x squared minus 10x plus 24. Subtract x squared from both sides. Wow, look what you get over here. You get no x's, and then you get 16 equals 24. Well, that means this has no solution to it. So there's only one solution to this problem, and it's 5. That's it. 1. It's 5. So someone says, could you check that? Of course you could check it. Where do you check it? In the original. You know what? Since this is the very last problem, not an exhausting problem set, although you may have found it exhausting, let's check the 5. Let's see if it works. Remember what I said about checking, though. It's dangerous, and I'll tell you why it's dangerous. You can make a mistake with arithmetic and think a correct answer is wrong, but I still want to check it. I still want to check it. So I think there's only one answer to the question. Let's put this down. So what do you get? Well, the first term, you would get 4 thirds. The second term is just 0. The third term, you're going to get minus 2 over minus 1. Well, the next term is going to be, what do you get there? You get minus 2 over minus 3. Well, that's going to be tough, isn't it? We get 4 thirds plus 2, and then you're going to get 2/3. 4/3 and 2/3 is 6/3. 6/3 is 2, and 2 plus 2 is 4. Everything works out beautifully. X equals 5 is the only answer. Again, this one led to a contradiction, and there's no solution to that particular equation, all right? There's no way that can be made equal. Only one answer. All right, I think we're at the end of this. Yep, there's no more questions, and we'll move to the next exercise set soon. Thank you.